Ready. I'll quickly pan across the back because internet people love to focus on what's behind the person and point things out. So here you go. There's all your stuff. Hey, James. Calm down. Stupid cats. Don't hold anything. Yeah, right. And I got lots of stuff behind me. Let's see. Let me, actually, you know what? I got a stream going on in the other room. I got Smarter Every Day going. After some Veritasium and some other learning things, I had to come in here and take care of some stuff. So let me go shut that off really quick so I hear that in the background. And then, oh fuck, I'll just take it with me. All right. I don't know if you were guys, if you ever watched those shows. I call them shows because they have lots of production value. Oh wow. Way more than mine, that's for sure. I got a cold sore. God damn it. I ate way too much chocolate and peanuts and other things like that this weekend, and alcohol because Teresa's family was here, and tomatoes and all the things that cause that. I had too much of it, and not enough sleep. Sleep will get you too, and all my stuff combined, and yeah, yay. Anyways, other than that, I'm doing fine. I'm doing fine. I finished a yeah, s'mores will do it for sure. Yeah, I finished a bio that I wrote for the media company. It looks like this is gonna happen. We've been talking about stuff, and it looks like it's gonna happen. It looks like they have me doing a few things, which is honestly kind of exciting. I will be, or at least it sounds like, a biography that I wrote for the media company. So a biography about me that I wrote so that they can pass my information around to the other employees and other departments, and they can brainstorm other cool ways of utilizing me. And I've done a lot of shit, and it's really hard to write about myself. I don't like to do that. It's not fun. But luckily, I had some documents from college that I had, from classes that I took, and then I also made some other stuff too, and added to old stuff and all of that. So, right? Yeah, I don't know about that. I gotta be careful. They've seen the channel, but if I link too much stuff, and they're like, "Oh, great, this guy swears a lot." But they were saying they want me to host a show, 2 shows potentially, which I can do without swearing. I mean, I've gone this far without swearing, and I can do that. Just don't get me too excited about something. Yeah, so I'm going to host a show, which I think would be a lot of fun. I have no idea how much of it I can talk about. I'd have to sign anything saying not to talk about it, so I think I could talk about it. A show about engine machining. I think it's engine machining or just machining in general. I'm not sure which. But they want me to interview people, get information, ask questions, talk about the thing, and all of that. And so, I'm not a machinist by any means, but I know how generally to operate the machines. I've written G code. I have done cam stuff. I've loaded tools. I know just enough stuff to probably break a few tools and all that. But I have done a lot of cam. I took a whole cam class. And if you know that's period of machining. That's actually what you're doing. Okay, so like if you don't know what that means, here's this. Okay, this is sheet metal in this case. This is part of my update for today. This is a sheet metal drawing. But if it was a solid, and I need to have the solid cut out, I'll just open one up and make this easier, right? Well, educate y'all if you don't already know. Let's do, that's the sheet tank. This one, let's do this one. So here's a solid that is machined out. It's all smooth and shiny, right? Okay, so this would start life as a brick of, say, 4x4x12 aluminum. Okay, so imagine this solid block of aluminum, and hiding inside that block is this beautiful piece right here. Like, hello, in here, I'm in here, let me out. Just waiting to come out. And so in order to get this out, I have to use end mills and drill bits and fly cutters and whatever
else may be ball end mills or whatever. You look at this edge here, it's round and smooth. So you could use an end mill on the side and cut this profile. But then when you get to these points here where it goes over, you might use a ball end mill to cut these soft angles on here and everything. And in the end, it's going to be machined. You're going to see machine lines because you can only do so much work to make these things smooth. Now, I have this, right? But how do I get it from here to actual product, right? It has to go through that step. Now, before I took all these classes on SolidWorks and AutoCAD and CAM and blah, 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 I didn't realize there's a major step in between these two. Aside from operating the equipment, I have to take this image or this solid and put it into another program and tell the program what kind of machine I'm using, what tools I'm going to use to make these cuts, where that tool is located in the machine, if the machine has a tool holder, for example, where it can switch tools on the fly, that big rotating turret, or not turret, but they call it tool holder, but, you know, baseball, absolutely. And so I have to tell it what tool I'm using and which surface I want it to use on those tools on. And then what it'll do is like, okay, so you want me to do this function with that. And then it'll plot the path that this tool has to take to cut this out. And, you know, it can't just go and dig out 2 inches of material at once. Tools and heads aren't that strong, so it's going to go, like, 60,000. Am I covering the mic?
I don't know what the mic is. I think that's a speaker. I don't know. All right, I'll keep trying. Oh, I bet the video's got the Zoom mic on, and it's putting over there. That's better? Okay, cool. So the machine comes in here and it's going to do these passes, 60,000 deep, and then go back again. Right, and just keep cutting down, pass at a time until it gets this final shape. So I have to tell it to do that. And so the cam or the program that you would use for that, there's tons of them. One of them is called Master Cam. That's one we use mostly in school. But, you have to program that function and then take that and feed it to the machine. And then do a test run on the machine and let it verify the program so there's no errors and make sure it's not going to start banging into things. Because if you run tools, you can go online and look up CNC fails and see all kinds of expensive tools get broken by either plunging too fast into something and breaking it, or not lifting far enough to come back and drop down again, and then going up half the distance, coming in, hitting, like, say this, and snap the thing over and break it, and all kinds of stuff. So there's all kinds of good fail videos you can watch. So, anyways, they want me to supposedly host this show about doing that, but focused on automotive stuff. But not just like, just boring and honing, but that as well, but also some of this other stuff. So that should be pretty exciting. Well, it's going to be a new show, with me. I think it's new. So let's see. Dun, 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 dun. I think they said they were calling it Making Chips or something like that. So this one, being part of this one, I guess. Unless they're borrowing the name from somebody, this isn't it. I don't know. I don't know everything about it, honestly. That's just what they were telling me on the phone. Be part of this. I think I'd be one of their dudes, maybe? I don't know. Unless they happen to be using the same name and didn't realize this name already exists. My fingernails are nice. One time they were long. I have nice hands too, by the way. So screw you, Paul. One time. Let's see. I wonder if I use my EDU subscription for AutoCAD in a different degree. I mean, if you're still at probably. My fingers aren't fat either. What are you talking about? They're nice. They're nice. Nice fingers. Let's see. I'm going back in the comments really quick. Make sure I didn't miss anything. All right. So there is there's that show. I don't know if it's this exact show, but it is a show that they called the same sort of thing. But I'm guessing maybe they didn't realize this show already exists. I don't see their name anywhere on here. I don't see the media companies on here at all. So I'm wondering if they goofed that up. Yeah. Anyways, so some show. Whoops, that's not it. Where we at? Oh, we're SolidWorks. All right, so back to the update. The update was, here is the lower tank for the air water intercooler that I am making. Now, holy shit, material right now is expensive. Was that my first swear word of the stream? Wow. I made it 11 minutes? Material is expensive, and this takes forever to cut, so machine time is stupid long. So this would take about 5 hours on an expensive machine to cut out. Now, that being said, how much does that cost? Well, 5 machine hours at 120 an hour. Ouch, right? Ouch. That's what, $600? So just the machine time on this would be about $600, plus the material, which is going to be another $75 or so. This one here is for Subaru, so that becomes the issue, right? It's now that being said, it doesn't have to be for Subaru. It's made to fit in the top mount location of a Subaru. Top mount air water oil cooler. The thing about water is that it can carry a lot more heat than air. And so I can have something much smaller pull out just as much heat as an air-to-air intercooler that is much larger. So I can make everything more compact. Now, the biggest reason I want to do this, right? Well, there's two big reasons. One, response. I like the response that a nice top mount provides. Okay, this is way overlooked, right? And tons of people will sit there and say front mounts don't hurt spool. Well, you know what? They fucking do. And they'll say we put it on the dyno and it didn't hurt spool at all. We added 50 feet of pipe and it didn't hurt spool at all. Well, that's because dynos are various different types have. Questions are pouring in. Dynos have very different types. A lot of them control either ramp rate or they're just an inertia-based run where you're accelerating some rollers. And when you make less torque, it takes you longer to accelerate the roller. And then the turbo has more time to spool up. And so as the turbo is spooling up, it actually spools up around the same RPM as before on the dyno. That's just the way it fucking goes. Because they're looking at the RPM threshold, and that's just how it happens all the time. I can do things that would hurt spool on the street or performance on the street, but on the dyno they won't show up. So there's definitely a difference. And people who have driven both can feel the difference. The throttle response is dramatically different between a long skinny pipe coming off the throttle body to something like this that has all this air right here, right? Now this is the key, right? If I'm going for throttle response, when I open the throttle blade, whoop, right, which is attached to here, right? If I open the throttle blade, when it opens, now I have a difference in pressure. And I want the air here to be ready to into the engine, okay? I want this air to be here and ready to go in the engine. If I have this long tube coming off, all this air is moving at one speed, right? It's moving at one speed, and then I open it up, and now this air has to accelerate. You have to wait for all this air to finally start moving and feed the engine, right? There is a time delay there. Now with this, right, I have all this air at a higher pressure. That's also important. It's at a higher pressure. And when I open the throttle body, this air goes whoop into the thing of all this available air. I'm not waiting for a narrow column of air to accelerate and get into the engine. I am allowing this plentiful area of air that wants to push its way into the throttle body. Okay, there's a difference. That's why top mounts always feel snappier. They just feel snappier. And if you haven't noticed that, then I don't think you're paying attention, because it's extremely obvious, especially on like a VF, man. You put a big, huge front mount on a VF, you can feel the difference. You can feel the loss in throttle response. You can feel the loss in turbo response. Like, it's there. So I don't want that. And I don't want to have a gigantic front mount blocking my radiator. Those are the two biggest reasons that I want to do this. One, throttle response is right there. And two, the rate, the airflow through the intercooler going to the radiator is blocked because of the gigantic intercooler in the way. And it always hurts. A lot of cars will suffer from overheating on the track because they can't get the heat out of the engine because the airflow to the radiator is way, way less. And they'll go through and buy $1,800 radiators to try and do better, and they get marginal improvements, when the fact is that intercooler is the reason that you can't get stuff into the radiator, right? So I want to alleviate that by not having a big front mount. That's not just a big front mount, but a bar and plate front mount, which is way worse for airflow. If you look at any airflow study for a bar and plate intercooler, what you'll see is that the bar and plate intercooler absolutely wrecks flow through the front of the car. Tube and fin does way better, but tube and fin's expensive. Tube and fin is what every OEM intercooler is made out of, for a reason, because air flows through easier. It doesn't wreck the flow. You will not find bar and plate heat exchanger on any OEM anything, plain and simple. And you won't find bar and plate in F1, Paul. You'll find tube and fin. Bar and plate is way it is, but you know what? It's super cheap, and like every freaking intercooler on the market is made out of it because it's cheap to make. That being said, the next thing I'm doing is a bar and plate front mount. Now, that won't be cheap, and it might not even be viable in the Subaru market because there's too many people in the supermarket that can't afford it, honestly. Tube and fin front mount. I said bar and plate, I meant tube and fin. Would never do a bar and plate front mount. That's dumb. So I'm doing tube and fin from my intercooler because bar and plate is crap in my opinion. Now, that being said, bar and plate has its place. Bar and plate, in my opinion, the only place in the entire world for bar and plate is drag racing. That's it. The duty cycle is low in drag racing. I mean, it's really high for, 10 seconds or so, right? And that's it. And then in drag racing, you start from a dead stop, so you have no airflow over the intercooler until you're already moving for a while, and by then you've put a ton of BTUs into the intercooler, and you start removing heat really, really late in the quarter mile pull. So the best way to do intercooling in drag racing is either with a large volume of water or a big bar and plate that has a lot of mass, which is why when you look at the drag racing cars, you see a lot of them have these huge bar and plate intercoolers that are like a foot thick or a foot square, gigantic freaking intercooler cores, like a foot by a foot, and they're like 2 feet long. Right? You're not getting air through that intercooler. Air is not passing efficiently through that intercooler, outside air, that is, right? Cooling airflow is not passing the intercooler. You're not relying on that. You're relying on the mass of the intercooler to absorb the BTUs that the turbo is putting out for the duration of your quarter mile pull. If that intercooler setup was on the track, it would be an abysmal failure. If it was in a road race, it would be an abysmal failure. It would not work. You get like a quarter of a lap in and you'd overheat, your intake air temps would start screaming through the roof, it just would not work, okay? Bar and plate belongs in drag racing, where they do a very short, very intensive burst of BTUs out of the turbo into the intercooler mass, and then that's it, that's all they need. Why street cars have these gigantic bar and plate intercoolers, like ETS has like their 5-inch now, or something like that, like, that doesn't make any sense. That's crap. That's shit, right? But a lot of those guys are, well, they want a drag race, right? And it's the best one for drag race they put on their car. And they don't realize that they're drastically impacting the street ability of the car, or I should say trackability of the car. Usually on the roads are okay. But sometimes those guys will see overheating on the, hell, my 15 STI that I got from my friend Brett down in California. When I got that car from him and it got hot outside, it would overheat. It would fucking overheat. Turn the AC on, thing would overheat so fast. Big ass ETS front mount in the way. Factory AC condenser, factory radiator would overheat. Like I wasn't even on the track. My RS used to overheat, but it is better than STI. Why is that? Because you got all that air being blocked. You can't get the air through the radiator, and you can't get the heat out of the engine bay. So I don't want to do that. I want tube and fin front mount or tube and fin heat exchanger. So I'm starting off air water intercooler. Like I said, they're more compact. They can pull out much more BTUs than you can get out of an air-to-air intercooler. So this one here uses a Garrett core. Oh, I forgot about the core thing. Uses a Garrett core, and it is rated, they say they're rated for 750 horsepower at the crank. This guy. And it's good size. Look at that. It's a decent sized intercooler core, right? It's a big brick right there. Small water holes. Really, really fine fin density. I mean, you can't even see through it very well. Like you can see like a little hint of light through it. I put it on this side, but the fin density is really high on this thing. It's really good. Really, really good. So this big old brick will pull 750 horsepower, it says. All you gotta do is supply it cool enough water and a heat exchanger on the other side. Just like every air water heat exchanger on all of the production cars like out there. More production cars use air water heat exchangers than they use air-to-air heat exchangers for intercooling turbocharged cars. Obviously, there are some. Subaru, air-to-air. Mitsubishi, air-to-air. BMW was air-to-air, went air-to-water. Porsche, usually air-to-water. Well, yeah, most people are air-to-water. Anyways, why is that? I don't know, because it's better. I don't know. It's really good. Now, one thing about air-to-water is that technically, if the system is not large enough, you will never get as low of an air temp as an air-to-air. Now, if you think about that, that makes sense, okay? Because heat transfer requires a difference in temperature for it to happen, right? There has to be a high concentration of energy and a low concentration of energy, and it has to go through there. Now, if I have one heat transfer event, if I have air-to-air, so my charge air is transferring heat to the aluminum body to the air passing through the intercooler. So technically it's two, but we're going to call it one, air to air. Then I can, in theory, get myself really, really, really close to ambient temperature. If I add another step, another heat transfer in there, if I go now from air to aluminum, aluminum to water, and then water to another heat exchanger to aluminum, and then aluminum to air, then now I have multiple steps along the way, and each one needs a delta for it to occur, so I can't technically get as close to atmospheric temperature as I can on the air-to-air. So for peak temperature difference, I should say, the air-to-air on paper exceeds that of air-to-water. The issue is the air-to-water, if sized appropriately, is almost always more consistent. The delta T doesn't change dramatically. The supply temperature of the water is about the same temp all the time, and your delta T across the intercooler stays consistent. Whereas with an air-to-air, typically, they heat up, they get hotter, and hotter and hotter and hotter and hotter, and therefore pull less and less air out, and your charge temp goes up and up and up and creeps up during a pull, especially if it's undersized. Or in a track environment. Now, that being said, in a track environment, you too could get the air to water, starting to get it saturated and overworked if the system's not big enough too. So both cases, you still have the possibility of that. Just with the air water, you tend to have more stability. And compact heat exchangers. So when it comes to space, I have a compact heat exchanger on top of the engine pulling as much air heat out as I have a big ass front mount, which means now I have a sixth of the piping. I go from my turbo to my intercooler right into the engine. So even less than a sixth of the piping. I have high density. I have a tube and fin heat exchanger in front of the car. So the heat from that intercooler goes into the water goes to the front of the car, goes to a nice tube and fin radiator at the front of the car that's this thick, right? It's this thick and doesn't block the airflow to the radiator nearly what an air-to-air intercooler would do. And we're talking like a fraction of it. All right. Bunch of questions are pouring in right now, so let me answer some of these real quick. Let's see, I'm going way back up. So top mount, and you're going to use water. Yes. What about heat soak from it being on top of the engine? Not too concerned about that. It doesn't get any more heat soaked than any other intercooler would sit on top of the engine. And with water going through, and I'm taking that heat, I'm actually putting it somewhere. Where with the top mount, you're not putting it anywhere. It just stays in the intercooler. With the air-water intercooler, at least I'm taking that heat from that heat soak and putting it in the front and getting rid of it. Heat exchanger in the front mount location? No, not. Oh yes, the heat exchanger will be, yes, but it can be anywhere, right? You can put it anywhere where you have adequate airflow. You can do it in the trunk, you can do it in the back. And the cool thing about the the water heat exchanger is that you're not adding intake tract piping, so you can put it anywhere. You can stick it on the roof. You can stick it in behind the car in the trunk. You can cut a hole in the trunk and put like a radiator. You can do whatever you want as long as it has airflow, and you're not adding more complexity to the engine's induction system, right? You're not adding a bunch of air or a bunch of tubes, bendings, or anything like that, right? This is where we talk about the torque box. Absolutely, Justin. That's exactly what I was talking about. And there is a difference. And the torque boxes that I've made for engines, we've seen really good throttle response and boost recovery. Even though there's more volume in the intercooler pipe, for some reason the boost recovery is really good because basically when you shut the throttle really quick and then you open it again, the air is still at a higher pressure in here and it forces in, so it reduces the time needed to keep the turbo going. So now you immediately have more air volume and mass going into the engine to help do that turbo again. Where in the front mount, typically what happens is you shut the throttle and that pressure wave runs all the way back to the turbo, whereas it gets dampened by my big box. That pressure wave doesn't hit the turbo as bad. Then, computer went to sleep. And then that wave hits the turbo, slows it down, or it goes through wherever your bypass valve is, and you have this reversion or reversal of flow in the piping, and then you get open the throttle blade again, and you wait for the air to come back again. It's going that way, come back, this whole back and forth thing with the boost box basically, or the torque box as I called it. We actually called it the mailbox. It looked like a mailbox. Some of the air would vent out, but it still had a source of pressure. And when you open the throttle again, right into the engine. And you can see that on the rally cars. Rally cars have that, actually. Okay. Water cooling, the air flow be that good or better than normal air cooling? If so, why don't high-end professional race teams use it? I think I answered that. High-end professional race teams, some do use air water, but not many. Typically, when you see that, though, they have entire systems and flow paths dedicated to this kind of thing. They have, like F1 has a super thin, tube and fin heat exchanger for that purpose, but they have these giant sides of the cars with huge ducts that, so those side ducts you see where they have the air come in the front and at the top, there's heat exchangers, and that's where the radiator's at. That's where the intercooler's at. They have those things in the car for that. And then in other cases, they may feel that maybe the weight is an issue or not. The system shouldn't be any heavier than a gigantic front mount by any stretch. So obviously I won't know until I make it, but that's That is the plan after all the piping and everything. Well, I guess the water's going to add something, but yeah. Inner chillers. Those are cool. I know some people that have the inner chillers, and they can get air temp below ambient, and that's really cool. I think even Dodge has that from the factory on the Hellcat or the Demon. One of those has it from the factory, or they use the AC to cool the charge. The cool thing about that is if your water volume is big enough and you cool it, you can get it well below ambient, and that's what's really cool about it. You can get it well below ambient, like 40 degrees intake air temp, charge temps. You can never do that with an air-to-air. Now, that being said, the best way to use that is to cool the whole system while you're driving gently, and then when you romp on it, you turn off the AC pump, and then you use that the room, I say room, right, in that BTU accumulator that is the water volume or water mass in the system. But yeah, those guys can get way below ambient charge temps. I mean, 45 degrees. Eugene, he works at Pure Turbos. He has one of those inner chiller systems on his, well, before it got wrecked. Did he sell the car? I haven't talked to him in a while. Anyways, he has one on his BMW. And he was showing me logs where it was 46, 45 degree intake air temps, and that's pretty cool. You can't do that with air to air. Mounted at stock tone location, it won't work for NA manifold cars. I'm guessing not. It is shorter than a top mount. I initially gave myself 11.75 inches, which is the size of a VA top mount intercooler from the base of the flange. Let me show you. Let me turn this camera around. So from the base of this flange to the top of the intercooler, which isn't shown here, all the way to the top, I gave it, so here, if we look at this way, this is the piped version of it. So the base of this flange here, the top of this, on a top mount off of VA STI is 11.75 inches, or was it 12 inches? I gave myself 11.75. I don't recall, but I gave myself 11.75. That's what I gave it, and it turned out to be less. So I did it in less than that. You see, I tilted it 15 degrees, 15.14 degrees to be exact, but I tilted it 15 degrees. Just to aid in the air coming through here and coming out. I wanted just a little more straight flow through this instead of having it come in like the factory top mount does. Make a hard 90 into the base of it and a hard 90 into the heat exchanger. If you looked at the top mounts of a VA STI or any STI really, the top mount intercooler comes out of the turbo. I'm just going to picture it right here. Out of the turbo, it goes like this, behind the intercooler to a Y pipe, and it splits up the Y pipe. Then it goes to a hole in the end tank. It's somewhere around here-ish. Hangs a 90-degree turn, bloop, that way. And then another 90-degree turn to go into the core. And that's just from where it comes through. It also then has to go in 90, 90 across, 90 again to fill in these areas. You go across the whole top of the intercooler core. So the air comes in and goes, wah, 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 hangs all these turns to get into the core, then to go through the core, then it goes into the throttle body. But you see the bottom end tank on the factory top mount is really, really skinny all the way across the bottom. So the air is coming out, it's hanging at 90 and coming down. There's not really any straight-ish paths through the bottom end tank on an STI. Everything's really compact. So I went a different way with that. Obviously, you saw in my nice pretty one, obviously the pretty one, I had the air being as smooth as possible. You know, nice flowing, sweeping bends, a little bit of taper to it, right? To try and reduce the restriction as much as possible. Unfortunately, that is way more expensive to make right now. And with current material costs and tooling costs, I'm looking at, just for the part, my cost would be about $460 for just the end tank to be cast. Then I have to do final machining on it, and I got to pay the tooling costs. And the tooling costs for something like that are around $16,000. Now, I'm not trying to build a $2,900 intercooler setup that I have to sell 1,000 of them to break even. That doesn't make sense. So the prototype is going to be sheets. It's going to be a sheet metal style. You'll see I took the main design cues of the other one and put them into square edges. So it comes in this way, and it's hanging a turn, 15 degrees off of 90. And then this one comes out, and it's as good as I can technically make it with sheets. I don't know if you guys have ever used SolidWorks or not, but the cool thing is that you can you can flatten the sheets. So like if I open this guy, whoopsie, wrong button. Shit. Oh, here it is, flatten. Bloop. Now, there's what I would cut out. Cut that sheet out, bend it at the right points, and I have an intake. This is going to be welded on tube, obviously. So I would cut out this piece with a hole right there. That's the shape. Bend it in a break, then glue the seams. Weld the seams together, and weld on this guy after bead rolling the pipe, and then put the intake air temp bung on the bottom right here as well. So that's the sheet metal function. I flatten that one. Does that one again? Okay, so I'm still open. Oh, that's why. Anyways, that's a cool feature. So this is what the prototype will have to be built out of. I have to do it this way, and depending on how good it performs, that might be the final two until these manufacturing costs come down. Right now, material is just outrageously expensive, through the roof. Plus, there's a ton of it sitting in the ports in California and San Francisco and Los Angeles and California and England and a bunch of other places. There's just hundreds of container ships sitting in the port with the hose that I need to make cooling mods, with the material I need to make the other parts. Everything is just really, really screwed right now. Someone out there is trying really, really hard to crash our economy by blocking out all these ships and saying, "Oh, we just want people to move the stuff." Like, shut the fuck up. People will move the stuff, but they're blocking everybody at the ports. So fun stuff. Eventually, though, material prices will drop, provided some stuff doesn't go really, really bad. Okay, let's go back to the comments here. I said that. So what I was getting at was that I made this shorter than the factory one. It came out to like 9 point something inches. So it's quite a few inches shorter than the top mount for an STI. So it'll have more room. So potentially the NA manifold might have enough clearance to the firewall for that to work. I don't know the answer to that yet. That honestly hasn't been a big concern of mine because honestly I don't like the intake manifold. It doesn't work very good. The injector angle is totally different. You just lay a set of TGVs next to one of those. The injector angle TGV is like this. Any manifold injector angle is like this. So what happens? You put an injector angle like this when it should be like this on an engine. That injector sprays right to the port wall. Fuel runs down the edge. It runs like absolute ass overall, and the gains are just not there with the NA manifold. I'm just not seeing it. There's some gains, but not good enough. Now, if you use NA manifold with the TGVs and you adapt some TGVs to it, now we're talking. That's a good way to do it. Whether or not this fits, I don't know. The cool thing is, though, this is not orientation specific. You can put it anywhere. You can tip it up on its edge and run a hose to the throttle body from it, right? It doesn't matter the orientation. It isn't like we're trying to duct air into it in a certain way. So if your setup needs it to be moved over some or turned down some or turned sideways or whatever, that's doable. And I have an NA manifold that I will mess around with and see if there's an easy way to make it work. But regardless, it should be pretty good. Okay, let's go back some more. Isn't each 90-degree bend equal to 3 feet of straight? I cannot qualify that statement. I can tell you that doesn't feel right. Doesn't feel right at all. And so much of that's going to depend on how close you are to choke flow in the pipe to begin with, and the velocity of the air as it has to go through the turns, and all of that stuff. That does not sit well with my intuition. I can't say that at all. I can't agree. Do not agree with that. That's why I put my heat exchanger in the rear of the car. Right on, John. Well, I like him back there too. It's really cool. Obviously, bunch of water pipes back there for like the radiator and stuff can become or can sometimes be problematic, especially with flow and that kind of stuff. But if you have the right stuff to get it done, then badass. I totally dig it myself. Good airflow exposure, an increased system volume. All those things are things I like about putting a heat exchanger in the back. Am I making it cooler for Subarus? I am. That is what's going on. The cool thing is, though, is that the design isn't so specific that it's only useful for Subarus. Because you could easily use this as the inlet and that as the outlet. Take it to a Mitsubishi and set it next to a 4G63. The throttle body sits right here. You throttle body and the turbo sits in front. Feed it, boom, boom. So like it could probably fit a 4G63. It's not very wide. Like I said, it's 11.7 on this angle here. You can do some maths if you wanted to and figure out how wide this thing truly is from one side to the other, but it's not very wide. So I bet that it could probably fit on a 4G, which is a little finagling and that kind of thing. So I guess the only issue is that this is 275 and that's 2.5. So that might not be as ideal to have it that way. But that same thing said, flip it around, have the turbo from the front feed there and have that come out the back of it and put a 90-degree coupler on it, go in the throttle body, something like that. Like I said, it's not a gigantic intercooler, and I think it will. I think it will be successful. Let's put it that way. Okay. Other comments? What do we got? What do we got? What do we got? Currently working through an air water setup on a 3S GTE, all-wheel drive Celica, so the insides are awesome. Oh, sweet. Yeah, I hope that any of this that I tell you helps you in making the correct decisions for your own project. I mentioned for your air temp with ace versus AF. That is actually a good thing at the point where air is cooler than ideal and feels atomized as well. Kind of. Really, the thing about air charge, and this is it's hard to for everyone to grasp, and it's hard for me to explain because it is. I've said before in multiple streams that you cannot, with any. How do I say this? Okay, you cannot accurately model the intake air temp, charge, intake charge temp. There we go. Right now, what's the difference? The charge temp is the temperature of the air when it finally gets into the engine. You can measure it at the throttle body. You can measure it in the manifold. But as it passes through the whole system, it's going to absorb heat from port walls and from valves and from the combustion chamber, from the piston and the fuel. Sometimes the air can be cool, in this case, cooler than the fuel. So the actual air temp is hard to figure out when it gets into the engine. And so with speed density stuff, we get really close because you need that charge temp to know how much actual mass is going into the engine. You don't need it as much with mass airflow because the mass airflow sensor measures the mass of the airflow. Past that point, you know it's going to the engine. You're said and done. Now, what does the air do? Well, like I think it was Matt or Justin that said, the air temperature affects atomization of fuel, and that's absolutely true. However, where we're talking about doing this is at a high power density, and there's going to be a lot of heat in that cylinder. The intake air temp at the throttle body might be 45 degrees, but it's warming up instantly as it goes to the manifold. It's warmed as it hits the fuel. It's warmed as it hits the valves. It's warmed as it sucks heat from the chamber and on the piston. It's going to get warm again. And that's one reason why I think that many professional racers run like 300-degree coolant temps. They want the air charge to be as cold as possible to maximize the amount of mass that makes it into the cylinder. But as soon as it's making its way into the cylinder, they want to absorb a lot of heat so that it has a more uniform combustion. Now, if I was to choose a less uniform combustion with a 20% increase in mass, or just a more uniform combustion with a 20% decrease in mass, I'm taking the less uniform combustion, right? The increase in mass is an increase in molecules available for combustion. And yeah, it's nice to have a nice high intake air temp charge that atomizes fuel really well while you're in cruise, while you're driving around, you get better fuel economy. That's great. But I want it to be as dense as possible in the intake manifold and get into the engine as efficiently as possible. The more density, the more it makes past that valve, right? Because that valve is a restriction. So I have that air cold as it's going through that valve. I will get more in the cylinder than what if the air was hot. And honestly, the gain in density is worth the reduction in combustion efficiency in most cases. That being said, if I have a super high cooling temp, when it gets to that engine, and as much heat's being pulled out of that cylinder, it's absorbing a lot of heat. Plus the high duty cycle, it's going to create a lot of. It's going to absorb a lot of heat in the chamber, the cylinder, and everything else. Not just that, but colder air that absorbs more heat takes more heat out of the engine with it, which improves your ability to keep the engine cool at high duty cycles. So while yes, cold air does hurt atomization at these higher power densities and higher power levels, I don't see any negative to it. Now, if we're talking about cruising down the highway, then absolutely there's negative to it. But if you cruise down the highway and you plan on just doing the cruising, then don't use the chiller. Just have it chill. Just have it relax, slow it down. And with the pumps, if you have an aftermarket system on it, you could run the pump slower if you wanted to reduce the amount of cooling that's being done. You could run it, if you wanted to, you could tie it to the fuel pump outlet. Out pump. Get maybe a gigantic fuel pump controller like from the GTR and run the electric pump off of that. And when the ECU sees full throttle and it pumps it at 100% duty cycle, have it run the pump at 100% duty cycle to push a lot of air through it, or push a lot of water through it. And when the fuel pump is at low duty cycle as you're cruising, 33 or 50% or 66, wherever you set it at in your ECU, then the pump slows down and the average temperature goes up a little bit and you improve your economy. So you have ways to do it. And that's on the factory ECU. With a standalone, I can do whatever I want, right? I can set it however I want. I can set timers that trip functions based on, oh, well, he hasn't punched it in so long. It's been going at less than this RPM for so long. Here's that. Then it can identify through logic that I'm now in a cruising environment, and it can reduce water flow or even turn off the pump altogether and then just have it sit there and let the intake air temp go up and improve fuel economy, right? Like all those things are possible. And then at, a few percent more throttle, it says, oh, here's a demand, initiates that pump, and all that water sitting in the heat exchanger in front of the engine is at ambient temperature. So bam, it immediately starts getting pushed into the intercooler and dropping into air temp pretty darn quickly. I could do any of that with a standalone, with an M-Tron or a Haltech or a Link, any of those. They all have logic in there that I can just determine a set of. I can do 3 ands. I can do ands and an or. I can do an and or and. I can do whatever. I can do and or and that kind of all kinds of logic stuff that you can set up to initiate functions, outputs. Things like that. So you can definitely do a lot of stuff with it. Turn off the chiller, turn off the water pump, let the air heat up, get good economy. You give it a little bit of throttle, or it sees, oh, he's been full throttle in the last 30 seconds, will maintain the chiller less than 60% throttle and run it until the counter exceeds a value over so many minutes where you haven't been full throttle. Then it goes, okay, now we're in a cruise mode, turns off the chiller, turns off whatever, right? And as it is, it's going to cycle the chiller with the AC compressor with throttle anyway. So when you, on the throttle, turn the chiller off, because the chiller is going to absorb horsepower, and the chiller would be the air conditioning compressor. Turns that off when you're at high throttle values. When you let off, kicks it back on for a little while, run some, pull some heat out. You're not utilizing power, let it pull the heat out, then you punch it again. then it turns off, right? So you can program all that to behave in a way that would meet your demand. And that's kind of a benefit too, the ability to let the air temp go up when you want. Whereas if I'm cruising on the highway in my STI with my regular top mount intercooler and it's winter, my air temp charge is really cold. The intercooler is really cold. I don't really have a way of warming it up much beyond using AVCS to do an internal EGR and heat it up that way. So to be able to warm it up more just from the initial get go, that would be advantageous. And I would bet that BMW already has that in the program, and Dodge probably does as well with their DM and everything. I bet they'll have something very similar to that in the program. I haven't seen it, but logic and the designer in me says that they would absolutely utilize something like that. Otherwise, why put it in the car? Okay, comments. Let's go back again. La 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 la. Okay, here we go. Heard 3D printing the casting molds for low volume production or even prototype. Yes. So absolutely can do that, and that's what they do. Actually, they 3D print the first spot to make the sand mold thing, and then they have the core, and they do all the stuff for the prototyping. But still, shitty. Where are you putting the BPV? That's a good question. It depends on the turbo. Some guys have EFRs with internals, but one thing I did notice though is that that they don't do as well with just the internal alone. So I like to leave that up to people, but ideally I'd want to put it on the hot side because I don't want to blow the cooled air out. Like the Subaru has the bypass valve next to the throttle body on the cold side of the intercooler, and that's neat and all, but you open that up and the air that's been cooled by the intercooler now goes out. So you take those, so you're basically losing the work that intercooler has done. So I'd run it here on the high temperature side. That being said, it doesn't screw directly onto the intercooler or onto the turbo, right? There's going to be piping in between that. So I need to leave room for people to do things, with the intercooler, because their setup's not going to be necessarily the same as this. For stock turbo stuff, I will provide a way of doing that, but for rotated setups, people need some flexibility in that. So that part of the kit isn't even in development yet per se, because I have to take into account as many rotated kits as I can, and all of that becomes very complex. And so what will probably happen is I will just have a length of pipe with a flange in it to allow people to have their blow-off valve in there. But for bypass valves, then it will go in here, because this whole area is much larger than even the factory intercooler provides, because it's usually like this over here, right? So I have plenty of room to put it over here. And this really only sticks a few inches past the throttle body. So while the intercooler itself is actually out to here, by comparison, this one is only out to here. So I have lots of room here for bypass valve. For stock stuff. But again, that's not where I'm at in this yet. I'm still trying to get my bill of materials done and get somewhat accurate estimates on what it's going to cost to get the intakes and the intercooler done. I know what the core costs. I know the pump costs. I haven't chosen exactly which heat exchanger I want for the front of the car yet. I have my sights on some that I think are going to be pretty cool. But there's still, portions that are definitely still in development for sure. Like, for example, the water box here will have to have either a cap for filling or a plug for filling or for bleeding, because this is going to be the highest part of the system. It's very high in the car. So I need something up here on the right. I've been going through several different ideas on what to do and how to take care of that. But also, I do have a ton of extra room here now because this one isn't nearly as wide as the other intercooler. So I've been considering putting the entire box here for the water reservoir here. I'm also considering for the VA cars or GRs and up, where the air pump is, that's where I'll put the water pump. That's something that has been on my mind for a while. We have a really good 60 amp service right there that goes to where the air pump is. And so for the race people that get rid of the air pump, they can put the water pump right there and plug into the 60 amp service. And then it only takes one wire to control the relay that controls the air pump. So that's also possible to have it nice and tight and close and just have it go from the water reservoir, which could be on the side of this, or in this region here, and then go to the pump, out to the heat exchanger, and back, just to reduce the amount of space needed for the kit. I hope that answers your question good enough. Let's see. Would ceramic coating the ports and the heads help that? Ceramic coating the heads and the ports could potentially reduce the amount of heat that the air absorbs. I know people have done ceramic coating of the chambers to help reject heat from combustion and to help uniformly distribute the heat in the chamber to the piston itself. So, Stewart EMP pump has even CAN bus control for speed. Oh, well, see, that's fucking sweet. Love the idea of trying the air water pump to speed, fuel pump speed. Yeah, I mean, it's not hard to do. Those controllers are available, and like this guy was saying, this EMP pump has CAN bus too, so we can tie it on its own circuit, or if, like I said, for cars that already exist with the factory ECU, just bam, you know, tie to the fuel pump setup. Yo, Kenneth, did you get your shit? Kenneth? Get your box with your cams and all that? Just kind of curious. Would you want the pump lower than the air pump's location for higher head pressure? Well, what I was saying is that the reservoir is going to be above it anyways, because the reservoir is going to be up here. So it's not like I'd had the pump as the highest part of the system, right? This is higher than the pump. And head pressure on a centrifugal pump is really only important if you have high temperatures. You know, so if I have it in the middle, I have the same, what I'm trying to say. It's not going to affect it much, is what I'm trying to say. Yes, if I had all the water down below, then that might create some, I don't think I'll run there either. I don't think so. I'm going to say no. I'm going to say no, it's not going to matter. I either have to lift twice as much water half as far, or half the water twice as far. You know what I'm saying? So I could check my pump laws and double check what it would take to do that, but I don't think it's gonna be a big deal. It's not like it's at the top of the system. It's in the middle. And again, I'm just brainstorming cool ideas. I think it'd be a cool idea to have it there. And I have all that weight of water on top of it that's in the core itself and the whole volume, expansion volume, etc. And the pump isn't like it's really high over the radiator either, right? The only water in this system is below the pump is like the lower 2/3, or, you know, I guess it's almost level, but it's still below the top of the radiator. So the lower, you know, 3/5 of the radiator water is the only water below the pump in the first place. So I don't really see, an issue with sticking it there at all. You didn't get it yet? Okay, cool. I haven't checked the tracking since I sent it to you. Did you buy anything else, Kenneth? Because if you did, I don't think I stuck it in the box. Let me know. I gotta double check. Because I think I just put the cams in the box. I'm thinking that's all I did. So if you did and I didn't send it to you, make sure you let me know. I'll take care of that right away. But you already had the pulley. Okay, that's what I thought. All right, cool. Okay. Cool. I'm glad. All right. So anyways, the major update for the air water cooler is, hey, I want it to be the smooth flowing cut shape, but right now that'll cost $600 and something per end tank to do because of all the machine time. That just can't fucking happen. So I have to do a sheet style. You'll see I got a taper on here too, to try and do the same things that my smoothness ones did. You see it tapered to help with flow, but obviously it's not a perfect flow, but it we're only talking from this to that, the smoothie one, only a few percent difference. And I think for testing this, it will be advantageous to actually have it be that, because if I do manage to get the castings done at a cheap enough price, since I've been getting quotes from everybody, if I can get the casting price down, it will be smooth like the other one, and that means that it will be even better performing than the sheet metal design. Okay, damper testing. Now people are curious about the damper testing. That has not started yet, and that's because the test car is not yet running. My in-laws came out this last weekend, and like I said at the beginning of the stream, lots of candy, lots of drinking, lots of partying and goofing off and no sleep. And as such, I did not get to work on the car, so it's not running. Also, I had to get a bunch of parts. Luckily, Tier 1 had parts available for me to use to fill in the small gaps of what I was missing to get the engine running, so they helped me out. It kind of feels like when I first moved here and helped Tier 1, I had a garage full of spare parts from MPS, and the first 2 or 3 years, I was just pumping spare parts to Tier 1 all the time. They were just getting parts and parts and parts out of my shop, out of my garage. So now it's the other way. Now I have to put this engine together, and I'm like, I need parts. So thankfully, Tier 1 had that. Thank you, Chase and Tanner and Lane. What else? But the oil did show up. So all the O-rings, all the bolts, and the silicone oil are here, and it is ready to go. I'm trying to figure out how I want to fill it. I designed a tool to fill it with a vacuum pump and some other stuff and all of that, and I definitely want to do that. But I'm curious if just assembling it in a bath, not obviously a bathtub, but submerged assembly would be better. I've been considering that. Unfortunately, oil is really, really expensive. So I have to determine how much waste there would be in that, but it'd definitely be easier than a vacuum pump. I'd be able to just assemble the whole thing underwater, but not water, under oil. And that would make it quite a bit simpler, I think. So I have to consider that as a possible method of installation. I think that it would ensure even less air than sucking it down to almost perfect vacuum and then emitting oil into it would do. So, my nose itches. So I would definitely probably, that sounds really good, yes. So I'm absolutely going to determine if that's the way to put it together or not. It was more messing around. I'll practice once and see what I got. I got some Tupperware containers and stuff. But yeah, that oil is like $2,800 for 5 gallons, or $2,200 for 5 gallons, something like that. It's really expensive. So having a lot of waste is not ideal because that means a lot of money, right? And I got to recoup my costs to make the product in the sale of the product. So I'm trying to make that as efficient as possible. That being said, I went through the SFI 18.1 regulations before I designed it, and I thought I had abided by everything, but I reread them again, and there's a spot that is questionable as to whether or not it'll pass 18.1 construction. So they have like minimum design requirements and then performance requirements. I have no doubts it'll pass the performance requirements, but they have minimum design requirements, and so I may have to thicken a few spots. There's only a few spots that need to be enlarged, or so it seems, by reading their rules. Some of it's a little weirdly worded, and I'm gonna have to contact the organization and send them drawings of it and how I interpreted their calculations, do that math, and see if I'm doing it right. And if I did, then I don't need to modify anything. If I do, then I can do a small change. It's not a big deal. It won't increase the cost of manufacture at all. And realistically, it would actually mean less time on the machine because I'm making less passes with a cutter. And the material's already there, it's just getting cut away right now, so it'll be less cuts. Granted, we're talking 10 or 15 seconds kind of thing. So that itself won't lengthen the time to production any, as long as I get a reasonably time-framed response from SFI on that. And then I still have to do the SFI certification. I still have to. This is what sucks. So I guess remember the SFI 18.1? SFI 18.1 is what they have for dampers. I think 18.1 is also for flywheels, but it might just be just dampers. And so what you have to do is have a test rig that has the damper attached to a fixture that looks like the front of the crankshaft. It has a affix the same way as it would affix to the crankshaft. And then you have to run it at 12,000 to, it's either 12 to 13 or 12.5 to 13.5 RPM for a period of an hour. And you have to have a way of logging that RPM over the hour and showing that the machine or that the product passed, right? It passed the test. So you have to do that. That's the performance requirement. That's really the only performance requirement. But there's also a material performance requirement, and that's a little weird. I have to take the material that we make it out of, the actual material from the manufacturer that I'm making these things out of, and send it to a lab to be tested to verify that it has the minimum tensile strength required, and the elongation is within spec and everything. So to test the material, be sure the material itself is not a crappy material and that it meets their requirements. What's funny about that is that their requirements vary based on the material used for strength. Well, duh, their materials have different strengths. But I can use a weaker one, or I can use a stronger one, and it's both okay as long as it passes. So I can have one that is stronger than the weaker rated one, but because it's, say, a steel, and it's stronger than aluminum, but it's not as strong as the steel, it won't pass, which seems really asinine to me. It should be the material itself needs to have this certain strength, because the next thing they give you is a thickness requirement, and they say that it has to be X thick. Well, I don't think it specifies thickness based on material. It might. I'll have to read that again. I could be wrong there. It might, but I don't think it does. But overall, the material thickness that they dictate in only one spot is thicker than my thing, my damper cover. But then they say that it only has to be thicker for a portion of the size of the cover, and they give you this formula. But they do it based on a weight that's just a ring, and my weight is not a ring because my weight has all the little ears and tabs that go into the chambers to control the damping rate. So I don't know how that applies, basically. So I don't know how that applies yet. So I have to send them drawings and say, does this work or not? What else? So damper testing has not started because I haven't got the cards going to run on together yet. But I have everything for it, I believe. So I'm going to get back to putting some shit on it tonight. And hopefully I will get the car running in the next couple days. I still need a downpipe. I cannot find a freaking downpipe to save my life. I need a catted downpipe, right? That's what I need. I would love to have an OEM one for the testing, but an aftermarket one would be great too. But I need a downpipe for this STI, and I cannot freaking find one. So that's a bummer. What else? I guess that's it. Jason, if you're watching, I hope you got my email. Those hubs for the Pro Hub. Material cost is, like I said, so freaking expensive right now. It's going to cost like $1,400 after I have them zinc plated and everything. So I am sorry. I am not able to save you money in that category, because I think you said they were $1,200 or $1,300 from Pro Hub. If they're $25, well, shit, yeah, we can save you money. But I thought you said they were like in the teens. So if they're in the teens, I'm sorry. I am unable to save you money on that. Material costs are too high. I think it was like $360 in material or something like that. It was just stupid. It was stupid expensive for the steel. And because it had to be like a 10-inch round, it was just really, really expensive for that. So I apologize that it's not cheaper. However, if that works, let me know, and we'll get them cut out and made for you. What other projects? Kenneth got his cams finally. The GSC cams that this is only the second set of billets that I've done my modification to, because I don't usually run GSC cams because I had beef with GSC. So I got to see just how hard those cams are again, get reminded how hard the cams are. The cams are hard, and that's great. It's good that they're hard, but that only addresses part of the issue. that causes the cams to fail, which is why GSC cams still fail. In fact, a friend of mine over in Oregon just had his second set of GSC cams fail in his race car. So there wasn't much time on them at all, and so he's been having issues. And so I am going to be modifying his next set for him. It should reduce friction, it should increase longevity, and should stop them from failing on him. But it takes a lot longer to do GSCs because they use a really, really hard billet. Like I said, that's cool because that also reduces camshaft flex. Flex is another issue that they experience in the EJ because the lobes are not evenly spread around the cam. There's 4 lobes on the cam, 2 of them are 90 degrees from the other 2, and that's it. Yeah, man, that sucks, dude. Did you have a failure at 2,000 miles, or the ones you sent me were 2,000 miles? What else? Anyways, so they are hard. They're very hard cam. Doing some stuff with my cams and some more testing on mine. I might need to use a larger exhaust cam to get the high RPM performance that I wanted to get out of them. So I'm doing a test with an existing car. Yeah, well, yours didn't fail. Sorry, that his comment says that the cams he had only 2,000 miles on the ones that I modified for him. Yeah, but his cams didn't fail though, so his cams were good. They had a couple weird wear spots on them that I was like, what is going on here? That was kind of odd. And I think that's going to be okay. It didn't look. That's really good. IG covered it for you for sure. It did. They didn't look damaged. It just had like weird wear spots that I thought were odd. I think they'll be okay. Yes, you should. Well, you got Kelfords too, so I can do the full thing with the low oiling and all that. As long as they're ADCS cams, I can do it. If there's regular 205 cams, then I can at least do the lobe treatment. That's saved tons of people. Anyway, so GSCs are hard, as I wanted to cover there. I'm doing a revision to my cams, to the exhaust side, to try and get a little more air out and increase the top end performance of them. Right now, the power curves are very linear. That's good. Yeah, single ABCS is great. If you look right here, I'll show you this dynagraph. This is Anton's. He had an 8374, and look at all the boost. The thing breaks 500 foot-pounds of torque to the wheels at 4,000 RPM. That's insanity right there. That's with my cams and an 8374 on a 2.5 liter. He has an NA intake manifold on it, but honestly, his power curve didn't look like it changed much between his old intake and this one. I think he actually lost top end horsepower with the NA intake manifold versus the regular STI manifold. I think he actually lost some top end with it. But you'll see here, the torque is still dropping as the RPMs increase, and the horsepower is getting pretty flat. So with all the spool and low end and mid range the thing creates is amazing. But I just feel like I need a little more exhaust lobe to get this a little flatter. That's what I think. That is what I think. If we look at old dynograph that I had with, where's the other one at? Let's see, where is it? I want to show my family pictures and stuff too, so let's go to dynagraphs. Here we go. This one here. See this one here? It's dropping, not as hard as the other one, because this is 6,500 here before it starts to drop down. And Anton's was dropping from 45 and just straight down. Anton has a much smaller header. That was the other data point that I noticed. His header is like a 1.5 primary, where the other one that I showed you there, that guy has like a 1.75 primary. And I think that larger primary is proving that my exhaust is a smidge restrictive of what it could be, because this one is trying harder to get stuff out of the engine, and therefore I'm losing a little bit of top end horsepower on it. But the other one, as you can see, is peaking at 65 before it even starts to fall. But he's got a much larger primary on his header than Anton's car. This is also 2.3 liters. So there's a couple things that are really showing me that I think the exhaust needs to be enlarged some. For as big as the intake cam is, I think the exhaust needs to go up a little bit. Bright side, it doesn't affect idle too much. So, man, that's such a beautiful power curve, though. I wish it was still a little more climby, but that's still a ripping curve. This car drives really nice. All right. I think that's it. I think that's everything I wanted to cover today. Yeah, I can't think of anything else. Sorry for the wonderful camera work. I think that's everything I need to cover. And I think I answered all the questions. Let me double check those one more time. Yep, single ABCS, perfect. We can do the full Monty on that. Takes longer and costs more, obviously, but the forced lobe oiling is really nice. Plus, it also increases the direct lobe oiling to the exhaust as well. So it's like double benefit. So really cool, and I think that your stuff would benefit from that. So if there's no more questions, I'm going to call it quits. It's been an hour and 15, and I need to work on some other stuff. So I appreciate you all stopping by. Oh, he did, Justin. He did get the new 8474. He does have it. He says it only spools like 100 or 2 later. It is the black, yep. And he says it's making like another 200 horse. It just absolutely rips. Haven't had it on the dyno with the black yet, but he says that the power increase is definitely there. So he did do that since the dyno tune. So he's pretty excited about that. And one day we'll get back over here and see what it does on the dyno. But 656 on the 8374 is still really darn good. And he said at a lower boost level, it's definitely faster at less boost. So yeah, it's pretty sweet, really. It's really sweet stuff. Oh, the Nova. Sean took the Nova racing. He went to a test and tune, and he couldn't get it up on the converter. Not sure why it wouldn't go. Well, I do know one reason why. He had it set to a different setting than last time we did it. I mean, there's no real wrong side of the end tank, right? It just depends on what you're trying to accomplish with it. The hot side or cold side, it's really up to like what you're trying to do. No, the Corsa Veloce has intake tuning, for sure. It definitely has intake. The only thing that gets rid of it is the mothership and the AMS. Those two get rid of any ability to do any effective resonance tuning at all. They don't exist at all. So, but the Corsa Veloce and anything with a common plenum will have some level of resonance tuning. But when you have the individual plenums or the sub plenums, then you lose that resonance tuning entirely. Which is why I don't like the AMS manifold. Yes, it makes power, but it's a gigantic short runner. It's going to make power. But they just took a 6-cylinder manifold, lopped 2 cylinders out and said, look, it's a 4-cylinder manifold. And in the Porsche that they basically took the design from, they had resonance tuning, right? And even Porsche didn't do that on the 4-cylinder. The Porsche intake manifold on their new 4-cylinder engines looks like the manifold in the Ascent, right? They did not do the common plenum one bank because it's wrong, plain and simple. So they didn't do it. Do I like the Cosworth? It's all right. I mean, it definitely increases flow, but you take a serious hit and spool with it, and it's if you zoom out on it, it's really close to how I would build one. If I was going to do just a single plenum and single runner size manifold, it's really close. There's a few things geometrically I don't like that I would change to make it what I think would be better. But it's close because I still get the cylinders timed correctly. They have it almost set up so there's almost like a subplenum going from front cylinders, and then a subplenum to the rear cylinders that are tied together by the throttle body main plenum. They kind of have that set up a little bit like I would do it, but I would do it just a little bit differently. But overall, I think they're on the right path. I think they put way too big of a primary on that thing because it's way bigger than TGVs. It's just too darn large. Yeah, Corsa Veloce and Process West are the same ones, Chris. So yeah, those maintain resonance tuning. And it's a good manifold, but any big manifold like that is going to hurt spool. When they're that freaking gigantic, they're going to hurt spool. The black plastic manifold does not hurt spool. They help spool, you know, like Justin's bringing that up. But it does reduce the power potential from other manifolds because it is a smaller, lower flowing manifold. But it can produce really wide power bands. It can spool turbos way faster than the factory STI one. It's really a good manifold, especially for a racer, a road racer. It'd be a great manifold. For drag racer, not so much, because it doesn't do the top end horsepower, but it reduces spool or lag dramatically. It's a really good manifold. I enjoy using it. I enjoyed when I had it on my cars and everything else. So that's a good manifold. But yeah, something like that with a larger plenum and a shorter runner would be more effective, or even a dual plenum, dual runner thing like I have drawn up. That one day I'll show you guys. Eventually I'll get that one done. That'd be really neat, honestly. Be really cool. But okay, now I'm going. Thank you very much. It's good seeing you guys. Happy Monday. I got a lot of stuff ahead of me this week. Got to do a lot of work. And if I get a chance to do some streams, I'll do some streams. Depends how the car tuning goes on some of these cars. If I'm pulling my hair out and swearing like crazy, then I'm not going to want to stream it. And things like that. So we'll see. We'll see what's ahead of me this week as far as future tunes or future streams. Sorry. Words are hard. Words are hard. Anyways, again, have a good evening, and I hope you guys have a great week. I'll see you later. Finger on the camera. There we go. I don't know why they do it there.